1.3 complex numbers. We're basically talking about imaginaries. So we mostly talk about real numbers in math, but now we're talking about imaginaries. So you can see kind of how it breaks down. Complex numbers, a plus bi. That's what it's going to look like a lot of the times. And so with a real number, your b number is 0, and that makes us not have any imaginaries. But for complex numbers, b does not equal 0. We're going to have an imaginary number, and so your answer a lot of the times is going to look something like 3 plus 4i. That's a complex number. Okay, so what is I? I is defined as the square root of -1. So we've always talked about how there's no such thing as a square root of a negative number. This is going to be our way around that. Okay. If you think about I squared is going to be useful a lot of the times. If we took that square root of -1 and squared it, square root squared, you're going to get -1. So something I want you to memorize here, I want you to make sure and memorize that I squared equals -1. That's very useful. Okay, that will be very useful to you. Number 1 says write as the product of a real number and I. All right. Once you know what you're doing, you're going to do this, in your head, and you're not going to show any work. Square root of -81. Square root of 81 we all know is 9, but that square root of negative is going to put an I on there. It's going to be 9i. Okay. Usually what you're going to want to do to show work on harder examples is split it into square root of -1 times the square root of the positive number, because we know that the square root of 81 can break down into a 9, and we know this is defined as I, so we can do it that way to show, but for the most part, the easy ones are the easy ones. If I gave you the square root of -36, I would expect everyone in here to just be able to blurt out 6i, okay? Very, very quickly. The easy ones are the easy ones. Part B is not quite as easy because we don't know the square root of 55. So if you got one like that, you'd have to try to break down the square root of 55, however you break that down. In this case, though, square root of 55 does not break down. And so we would just say, well, I know the square root of -1 is I, but square root of 55 is just square root of 55, and that's all I can do. So you would actually enter your answer as I times the square root of 55. Now, somebody might ask, why don't you write it backwards? And you could write it backwards, but it's a little bit tricky because sometimes people might write it like this, and it's kind of difficult to tell if the I is supposed to be inside your square root or not. And so I think in order to prevent that problem, a lot of people will put the I in the front. Nobody's going to make that mistake and think that I is inside the square root if you write it in the front. Next one, C. We can split that into square root of -1 times the square root of 98. Okay, and we know that the square root of -1 is I, but that 98 can break down. I believe we've talked about this before. We can break it down because we know the perfect squares. Square root of 1 is 1, and square root of 4 is 2, and square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7. Aha! I can break down the 98 into square root of 49 times square root of 2. I do that because I know the square root of 49 is 7. And so if you put all of your parts together, you've got a 7, you've got an I, and you've got the square root of 2. That's your simplified answer. It's a very common type of problem. Make sure you can break that down in that way. Number 2, we've got several different more complicated things we're going to have to clean up there. Okay. This one, I think sometimes this one's tricky because people see a negative times a negative and want it to be a positive, but that's not exactly how this works for imaginary numbers. Okay. That's not how it works for imaginary numbers. So my advice to you would be always split it up. Okay, you've got square root of -1, square root of 21, times the same thing. Or I times the square root of 21 times I times the square root of 21. You've got two separate imaginary numbers. And if you multiply two separate imaginary numbers, you're going to get I squared. Square root of 21 times the square root of 21 is 21. But you've also got an I squared. And I told you to memorize earlier. What is I squared? I squared is -1. Memorize that. So we have -1 times 21 equals -21. Next one. Let's skip a step here and just say that negative is going to be an I. Okay, square root of -1 is I, so we're going to have I squared of 5 times I squared of 30, right? Well, we can combine our radicals. We can multiply those and get 150, but we'd have I squared times the square root of 150. Well, we should know that I squared is equal to -1 because we have that memorized. But that 150 we'd have to break down. And 150, you don't just want to break it down into anything. A lot of times I'll see people just do the first two numbers that come to their head, 15 and 10 or something like that. But that's no good. You can't do that because I don't know the square roots of 15 or 10. You don't want to break it down into just anything. You want to break it down into something that you know the square root of. So you go back to that list again. Okay? That list right there of numbers you know the square roots of. And I know 25 goes into 150, so let's try that. 150 is 25 times 6. Okay, so good. I know square root of 25 is 5. So if you put your pieces together, you've got -1 times times 5, sorry. We would get -5 times the square root of 6. Part C, again, it's tempting to just cancel out those negatives, and sometimes that works and sometimes it doesn't, but it's kind of tricky. I would advise you to not just cancel out the negatives first. You've got I times the square root of 42, and you've got I times the square root of 3. Okay, so those I's actually do cancel out. When it was I times I, it was I squared, but I divided by I, we can cancel out. But we can also reduce a fraction because we know square root of 42 over square root of 3 is the same thing as square root of 42 over 3. We can cancel. 3 goes into 42 14 times. So if the i's cancel out and 42 divided by 3 is 14, we end up with the square root of 14. Next problem, we have I times the square root of 63 over the square root of 21. You can rewrite it as 63 over 21. Oops, not 61. 63 over 21, because 21 goes into 63 3 times. Now, honestly, guys, I don't mind if you skip that step and go straight to here. I don't mind if you skip a step there. Either way, you're going to get square root of 3 there. It's I times the square root of 3.